Okay, now we're going to talk about the idea of rational functions. So all we're doing in this case is we are taking a rational expression and giving it the name of a function. So in the example I have here, I said let f of x equal 5x over 3x minus 9. So what I've done is I've taken the rational expression, 5x over 3x minus 9, and I've given it a name, f. So remember that when I'm evaluating a function, whatever value replaces x is what I put into my function. So if I want to find f of 1, in this case, what I do is wherever I see x, I replace it with 1. So this is going to be 5 times 1 over 3 times 1 minus 9. So on the top I have 5, and on the bottom I have 3 minus 9, which is negative 6. So the value of my function at x equals 1 is going to be negative 5, 6. If I do the same thing for negative 3, f of negative 3 is equal to 5 times negative 3 over 3 times negative 3 minus 9. And that's going to give me negative 15 over, well, let me rewrite the denominator here correctly. So it's going to be 3 times negative 3 minus 9, like that. So negative 15 over negative 18. Now I can simplify that because 15 is divisible by 3, so that becomes a negative 5, and 18 is divisible by 3, so that becomes a negative 6. So I have negative 5 over negative 6. This is equal to a positive 5 over 6. Now lastly, let's look at f of 3. So f of 3 is going to equal 5 times 3 over 3 times 3 minus 9. So this is going to be equal to 15 over, well, 3 times 3 is 9, and 9 minus 9 is 0. So this is undefined. Undefined. So in other words, we can't put 3 into our function because it makes the denominator 0. So if you remember, the domain of a function are all the numbers that you are allowed to put into that function. So for a rational function, the domain is going to be all real numbers except for those that are excluded values. So if we look over here at f of x, and we notice that the denominator is equal to 3x minus 9. Well, if I set that equal to 0, that means that 3x is equal to 9, and we wind up with x equal to 3 as our restricted value. So what we can think about here is that I've got the entire real number, or the entire real number line. Okay. And any number on that number line is part of the domain of x, except for an open circle right here where x equals 3. So if I wanted to go ahead and write this in interval notation, okay, remember when I do interval notation, I'm always going to start as far left as possible and keep going until I hit my first number. So I start with negative infinity, and negative infinity always has soft parentheses by it, and I keep on going until I hit 3. 3 is an open circle, so that means I put a soft parentheses by it. Now, remember, I connect pieces of interval notation by putting u's in between them. So I end at 3, I put a u, and the thing is that 3 is also where I start up again. But 3 still is not part of my domain, so I use the soft parentheses, and then from there I keep on going out toward infinity. Okay? So you can see when I do the domain, I'm going to have breaks right here at my restricted values, like this.